Very, very important. So we are doing now, you know, the process too long, no? And this is the reason that we are doing using computers. So I want to explain in detail today how we are doing using software. Okay, the software that we are using is Geogebra Classic. Geogebra Classic. There are several versions for the Geogebra. We are using Geogebra. I want to show you in detail. No, don't worry for this. So for example, one example that we are doing is this example. You have, for example, x minus y equal 6, and 2x minus 3z equal 16, and 2y plus c equal 4. Equation 1, equation 2, equation 3. Okay, so first of all, it's important for your interpretation the potential solution that you want to get. And this example, okay, by the way, it's example 1. How many variables we have? How many variables? Number of variables. How many variables we have in that problem?
3.
3. How many equations we have? Number of equations. How many equations we have? 3 also, no? 1, 2, 3, no? So 3 minus 3 is 0. And this give me 0, okay, this represent the degree of freedom, no? Freedom of the solution, no? Solution object, mathematical object. So this is 0, degree of freedom is 0. That means okay, we have a point. So we have different objects in 3 dimensions or in multi-dimension. Suppose 3 dimensions. In 3 dimensions we have a point. A degree of freedom 0. Degree of freedom equals 0. We have a line. A degree of freedom equal 1 because it's 1 dimension object, no? The line have only 1 dimension. When the degree of freedom is 2, we have a plane in 3D, and so on, right? So you have no 3D, you have more than 3 dimensions. It's impossible graphic, but it's possible algebraically to understand that. We have different hyperplane, it's a special plane in multi-dimension that you don't understand very well what is the shape of this plane, hyperplane. Suppose another example that we're solving today. To understand this idea, this is example 3, no 2, example 3. Example 3 say, example 3 is 2x plus y minus z equal 4, equation 1. Minus x plus y plus 3z equal 1, equation 2. And that's it. This is the system. Again, you analyze this equation. How many variables we have in our problem? How many? Number of variables. How many variables in our problem? How many?
3.
3. How many equations we have in our problem? How many equations? 2. Entonces 3 minus 2 is 1. Entonces 1 degree of freedom. Entonces I suppose que in this case never, when you have 2 equations in 3D, we have no point solution. Because degree of freedom is 1. So you have a line solution. So we have infinity many solution. Okay, we have a line or maybe a plane, depending. No, it's a line, basically, it's a line. But it's important to understand that when you have the same amount of variable and the same amount of equation, basically this system is called defined. Determine system. When you have the same amount of variable and equation. Degree of freedom is 0. So maybe we have a point. Oh no, wait a second. This is the complicated part to understand. Suppose that we have one equation que is depending of the another equation. Depending is, do you remember? Suppose the stupid equation like that. Look, suppose that you have 2x plus 4y plus 3c equal 10, no? And we have this equation is x 2x plus y plus c equals 0. This is no, and you have, for example, 4x plus ay plus 6z equal 20, no? Do you see that the equation 1 and the equation 2 is dependent, right? Because the only thing I did was multiplication by 2. So this is depending. And the number of the equation, the substitution here is the equation for the linear independent. Equation. So you have one equation that is dependent. This is nothing. And you delete. But in this case, it's easy, it's straightforward because I create intentional to illustrate this. But sometimes it's not obvious. However, the elimination process, the Gauss-Jordan, or the Gauss-Jordan, is the most powerful. Illustrate you very well. See, my system have or have no the one equation that is linear depending of the another equation, and delete this equation. Okay. Entonces, let's do it now. Let me start for this first example. In the first example, immediately I try to write a metric language. This one. Let me delete that part. Okay. Now I write a metric language. A1 is -1, S0. One line can separate the coefficient and the variable and the right-hand side number 6. Remember, this column is the column of the x, this column is the column of the y, this column is the column of the z, and this column is the right-hand side number. And each row represents one equation. This is equation 1. I don't need to write this, but you can. The second is 2, y is missing, and -3 and 16. This is my second equation. And this is the last equation, que is no x is missing, 2y positive, 1z, and 4. By the way, this matrix is 3 by 4. Remember, this number indicates the number of rows. Okay, 3 because there is perfect coincidence with the number of the equation, 1, 2, and 3 equation, and 4 columns because is the 3 plus extra column of the right hand side, correct? Okay, now I want to show you how you open. So far it's okay, guys? Everyone follow me? Yes or no?
Yep.
Yeah. Okay, now let's go to Geogebra. Geogebra is a software similar to Desmos, but it's more powerful than Desmos because it contains that part of the matrices. Okay, so when you open Geogebra Classic, I want to show you in detail. When you open that, you go in the menu to the view, because they are different view, and you select algebra, 3 view, algebra 1, so you get algebra 1 and algebra 2, but no, only algebra 1. You select another view que es Computer Assistant Software, CAS, is the name, and you select another que es Spreadsheet. Spreadsheet. Okay, it looks like similar to the Excel. This is super important because we can edit in the spreadsheet Excel. Okay, actually, no Excel is Geogebra. You put the number in the order, 1, -1, 0, and you create the matrix. And when you create the matrix, automatically that matrix is transferred to the algebra 1 view. In the computer assistant software, you apply the reduce row echelon form of the corresponding matrix. You put the name of the matrix. I don't know, CSA, CSB, default. The software put M1, M2, matrix 1, matrix 2, matrix. If you want to change the name, you change the name. No problem with this. So let's move on to the software. I want to show you my browser. Okay, let me try to do share browser. Okay. Do you see my Google Chrome?
We see.
Of course, I have a shortcut here to see directly to Geogebra. Not necessarily, you type in here, Geogebra Classic.com. No? I type in here, bam, click here, and this is the environment of the Geogebra. Do you see? Everyone follow me? Everyone follow me?
Yes.
Okay.
Yes.
I click here in this 3 line. Here I select view. When I select view, I see several view. This is algebra. Algebra, no one. Algebra, just algebra. Graphic, no. I don't want graphic. I want CAS. I want spreadsheet. Bam. Close that. You can extend a little bit. Spreadsheet, algebra, and CAS. Do you want to do this in your laptop right now or no? Because one possibility is you're watching the video and you repeat again at home by yourself. No? What is the most convenient way for you, in your opinion? Do it simultaneously with me or after? Or only pay attention now, copy in your notebook? Come on, guys, answer me.
I think it's just better if we copy it in our notebook right now.
Okay.
Yeah, I agree.
Okay. Super. Okay, let's do it. Entonces, my first problem que I translate to the matrix language is you copy, for example, you copy here in any place, in any cell of this, you copy 1, -1, 0, and 6. And this is my first equation. My second equation is 2 log -3 and 16. And you moving here, feel free to moving, typing any cell similar to the Excel. And the last equation is 0, 1, and 4. Everyone follow me? I finished the editor process. Before this software, the students need to buy graphic calculator. It's the only possibility to do this. Now in the internet, in the modern software, they are not only Geogebra. I like Geogebra, but you have another software like a Symbol Lab that we can use in this. Okay, does everyone follow me so far?
Yes.
Okay, now I select the matrix or the hypothetical matrix I want to create. You right click and select create matrices. Boom, I did that. And this is the matrix. Okay, by default they call matrix 1. If you want to change the name, no problem. You right click and rename. Pero no, it's okay. This name is okay. This is, remember, this is a spreadsheet. This is algebra, I suppose. And this is CAS. Okay, CAS is they have the histogram, the summation symbol, Greek letter or something. This is more complicated part. And you type in here, this is the most important moment, pay attention. You put reduce a row in capital letter, reduce it. Oh, I start typing, immediately I see, reduce the row echelon form, matrix, bam. Now, what is a matrix? Well, the matrix in our case is M1. M1. No, no capital. M1. And you press enter. Bam. And this is the answer. Wow, amazing. Interpretation this answer. Interpretation this answer. Okay, I want to copy in my piece of paper. Okay, now the action of the reduce row echelon form is you have one pivot, and below and above the pivot you create 0, 0, 0, 0. In the right hand side you have the solutions: x is equal 8, y is equal 2, and z is equal 0. Let me come back to the whiteboard to illustrate very well this idea. Do you see the whiteboard? Do you see?
Yeah, we do.
Okay.
Yeah.
Let me erase that part because I want to illustrate that when you apply, this is a symbolic way. You put in the text something like that. One arrow, reduce row echelon form. This is the name of the operation. We get that. 1, 0, 0, 0, 1, 0, 0, 0, 1. I want to anticipate that this matrix can contain only 1 in the main diagonal and the rest is 0. This is called identity matrix. No, this is not important now. Okay, and you have after the bar, you have 8, 2, and 0. What is the interpretation of this? Well, so you translate the from matrix to equation. Remember, this column is x, this column is y, this column is z, and this is just number, right hand side number. It's 1x plus 0y plus 0z is equal 8. 0 is nothing, and 1 is invisible, multiply it. So x is equal 8. Likewise, y is equal 2, and z is equal 0. So now we have one solution, degree of freedom is 0, Esa the mathematical object que representa the solution set of this system is a point, and the point que es represent en 3D, like a triple order A, 2, 6. Any question? Any question? Do you understand?
No.
No, what part no? No question?
Oh,
Or
no. I was saying no question. Yeah, sorry.
Okay.
Yeah.
Okay, let's move on to the second example. It's a little bit more complicated. Not complicated. It's not. Nothing is complicated here. It's long, just long. And doing by hand, this is crazy. Nobody doing by hand. You need to know exists this software. And you apply. And the most important is interpretation of the answer. We have a system. Let me show you the system. X plus Y plus Z plus W. Wow. Another variable equal 4. Equation 1. Negative X plus 2Y plus C equal 0. 2X plus 3Y plus C minus W equals 6. And finally we have minus 2X plus Y minus 2Z plus 2W equal -1. Equation 4. How many variables we have in that problem? How many variables?
4.
4 variables. How many equations we have?
Also 4.
Also 4. The answer is 0 degree of freedom. That means que maybe, because maybe hiding, we have one equation que is dependent, no? I don't see very well because it's confusing, and this is impossible to see when you have 20 equations. You see, these 20 equations are totally linear independent, or one equation dependent of another. No, this is crazy to see using the eyes and the computer. Yes, of course. And what should I do? Bueno, entonces the classification for this system is determinate. It's determinate, no underdeterminate. Under is when you have, remember the example that I did before, you have 2 equations and 3 variables. Entonces we have like a lack of information, so it's underdeterminate. In this case, it's impossible to have degree of freedom 0. So in other words, impossible to have a 1-point solution. You have infinity solution for sure. Okay, but in this case, you have maybe the possibility that you have dependency. The equations are independent or no. You understand what means independent, right? Dependent or independent, linear independent. This is a hyperplane in 4 dimensions, X, Y, Z, W. See, these hyperplanes are parallel. It's dependent, right? Okay. Now, let's write this problem in matrix language. We have 1, 1, 1, 1, and 4. This is my first equation. Remember, the organization is clear. A column of the X, column of the Y, column of the Z, and column of the W, and the right-hand side number. This is my first equation. My second equation is -1 to +1. W is missing, is 0. Here it's like equivalent to say W, no W. And the right-hand side is 0. Okay, 0 is a number. 2, 3, 1, -1, and 6. My third equation. And my last equation is -2, 1, -2, 2 positive, and negative. Okay, by the way, this matrix is 4 by 5. 4 row, 4 equation, and 5 column because we have one extra column is the right hand side. This is called augmented matrix. Augmented matrix. Okay, let's move on to the Geogebra. Let's move on to Geogebra. Geogebra. Do you see Geogebra? You see?
Yeah.
Okay. Okay. The you put a space here, not necessarily together, and you put here 1, typing in the keyboard, your own keyboard. 1, 1, 1, 1, 1, and 4. In the second equation, and the 1. 1, 0. It's important that 0 indicate the W is missing in this equation, and 0 again. Third equation is 2, 3. 1. No. 1. Press tab, and you change the column. 2, 3, 1, -1, and 6. It's important if we make a mistake in one number or in the one sign, it's completely different system, and don't expect that the answer is good. This is important. Everyone make a mistake. Type in this. 2 and -1. Okay, let me check in just in case. 1, 1, 1, 4, 1, and 4, -1, 2, 1, 0, 0, 2, 3, 1, -1, 6, -2, 1, -2, 2, and -1. Good. Remember again, selection, the range, right click. You create different object, you create table, list, no, but on matrix is our object. And this is a moment to check in this. Okay, you have in the piece of paper. Huh? It's the same, right? So you copy here and cast. Again, reduce a row, reduce a row, reduce a row, echelon 4 of the matrix. Okay, the name is M2. Enter. Boom. You get the answer. One more time. After the reduce a row echelon 4 operation, I can see the famous identity matrix, que es the matrix contained in the main diagonal 1, 1, 1, and the rest is 0. And after the line, que in the computer don't write the line, in the paper yes, but in the computer no, is the right hand side solution. Es obvio que X is 2, Y is 1, C is 0, and W is 1 is the answer, right? Okay, let's come back again to the whiteboard. Sorry, whiteboard. Do you see whiteboard?
Yeah.
Yes,
So the operation que I'm doing in the software was put the arrow RREF, reduce the row echelon 4, and you get the famous identity function 1, 1, 1, 1 and the rest is 0. Below and above the pivot. In the right hand side, I saw 2, 1, 0, and 1. Therefore, I know how to interpret this. X is 2, Y is 1, and C is 0, and W is 1. In this case, degree of freedom is 0, because the solution is a point in 4-dimensional space. 2, 1, 0, 1. So X, Y, C, and W. Any question, guys? Do you see it's super powerful this? Because the idea is the computation by hand of this is very tedious. Not hard, tedious, long, consuming time. And in the long process, everyone make a mistake. So you make a mistake, I make a mistake, typing the matrix. I suppose I don't make a mistake solving the matrix. The important is the interpretation. The interpretation is, when you have here, look, interpretation is, you have identity matrix. Capital A is identity matrix. Okay, by the way, 4x4. 4 row, 4 column. This is identity matrix. Look, let me show you identity matrix. I represent like a capital I. You have the bar. Here we have a number, 4 number, 2, 1, 0, and 1. Okay, so when you this format not always the same. This is an important thing to do today. It's not always the same format. Okay, you have identity matrix here, completely identity matrix. It's unique solution, only one. Unique solution, degree of freedom is 0 and 4-dimensional space. Okay? So far it's okay, guys?
Yeah.
Yeah. Let's move on to example 3. Okay, the example 3 was the example that I put at the beginning to illustrate the case it's impossible to have unique solution, no? Because this system is completely underdetermined. Example 3 is 2x plus y minus c equal 4. Equation 1. Minus x plus y plus 3c equal 1. Equation 2. So we have only 2 equations and we have 3 variables. So the number of variable is obvious que 3. And the number of equations is 2. We have 1 degree of freedom. That means it's impossible this system have 1 point solution, 1 unique solution. No, because the point is the geometric object that have no dimension. So this is a line. It's a line under the consideration that these equations are linear independent. Okay, I suppose that yes. This first equation represents a plane. The second equation represents another plane. Suppose another plane like that. And the intersection between the plane is, okay, that part is missing. You don't see that part. And the solution is the common point is that line. That is the reason que degree of freedom is 1, que represent the solution object have dimension 1. And how you represent algebraically? Remember when you study in the other chapter, we don't know matrix, we define the free variable. Free variable. Free variable es the variable que es all real number. O sea, suppose que X is all real number. This is free, no restriction, all real numbers. So now, when this situation happens, the solution, we express it using one free variable because the dimension of our solution object is 1D because it's a matter. Okay, but no more blah, blah, blah. Let's move on to Geogebra. You type in this and you solve it. And let's see what happens and what is the interpretation. Okay. Okay. Okay, sorry. Do you see Geogebra? Do you see yes or no? Help me. Help me.
We see it.
Yeah. Okay, this is the part I don't like of the online class. Because you see my face, you see. You see or no? You say, yes, professor. You say, now you are hiding here in your house in front of your laptop. And now you don't answer because you're waiting for another student answer. No. The student can always help me. Continue help me, please, okay? So now is, I take my keyboard, I typing. It's 2, tap, 1, tap, -1, press tab key, and 4. Okay. Now enter. I change the line. Entonces, -1, tap. +1, tap. 3, tap. And 1. Enter. Finish. This is my system. I select, right click, create matrix. Boom. This is example 3 and the name of the matrix is M3. And you now apply the fantastic algorithm, reduce the row echelon, reduce it. Remember I told you, okay, I want to explain 3 different algorithms. This is the first one. Okay, I did one example by hand. Remember the last class, it's crazy, no? It's too long. Okay, of the matrix M3, N3, N3. And press enter. Boom. Wow, look at that. I don't understand anything. Okay, what is that? I don't understand anything. Okay, let me try. I come back again to the whiteboard. Do you see very well the idea in Geogebra? Do you see yes or no? Do you see?
Yes.
Okay. We come back to the whiteboard to see the interpretation. It's the most important. So the engineer and scientific solving the system using matrix. However, the scientific or engineer interpretation this answer. Okay, this matrix, I forgot to write here, is 2, 1, -1, 4, separated by bar, -1, 1, 3, and 1. This is X column, Y column, Z column, and right hand side column. I put in Geogebra, I apply reduce the row echelon for, I get that answer. 1, 0, 0, 1, -4 third, 5/3, 1 and 2. By the way, this matrix is 2 by 4, and this matrix is also 2 by 4, no? It's obvious, right? Now the interpretation that I know que the solution is a line, never a point. Entonces ahí sí clear like water the famous identity matrix here. Okay, so this is the format. Look, the format is, you see here, identity matrix. Capital I is this identity matrix. Remember, identity matrix is a matrix, the main diagonal is 1, 1, 1, and the rest is 0. But this is dimension 2 by 2. 4 elements. Entonces, in the other scenarios, we have identity matrix on the right-hand side. But in this case, no, we have extra column. Okay, no bar here, no bar. I make mistake. We have extra column. Let me see column. C column. C extra column. Bueno, no, like a vector. Let me call this guy. Let me call this guy like F. Like one, no separated by entries, you know, by F, capital F. Capital F. Okay, capital F. And the famous right-hand side is 1, 2. When this situation happens, when you have extra column, it's because we have the free variable. This is the free variable. This is the free variable. The famous free variable. And the free variable, well, this column is the X column, this is the Y column, and C is the free variable. Wow. Entonces, how you write the final answer? Well, the final answer, you are doing equation by equation. The first equation say X, 1X, no Y, Y is missing, minus 4 over 3Z equal 1. If you declare C like a free variable, then this equation is X is equal 1 plus 4 over 3Z. Likewise, in the second equation, no X, Y is 1Y plus 5 over 3Z equal to. Now, Y alone is equal to minus 5 over 3Z. Okay, and this is the solution. The solution of this system is expressed like a cell building notation. Is the X, Y, Z. Remember, we are working in 3D space, 3 variables, such that X is connecting by Z using that formula, comma, Y is connecting with this formula. And what about Z? Well, Z is free. C is all real number. You declare C like it is all real numbers. And this is the solution space or solution object. Que obviously the dimension of this space is 1 because we have one free variable. And so you can represent in 3D, represent that line. Super clear or super confused?
Here.
Okay. Okay, very well. Let's move on to example 4. To understand any possibility. The most important for me is the interpretation. So you set up, step number 1, set up the matrix associated with the system, put it in the computer using Geogebra or another software, and now the answer that you get is the interpretation. Okay, let's move on to example 4. In example 4, we have another situation. Suppose example 4 is 2x plus 3y minus c equal 3. Equation 1. The second equation is x minus y minus c is equal 0. Equation 2. This third equation is minus x plus y plus c is equal to 0 again. Wow, weird. And x plus y plus 3c equals 5. Equation 4. Wow, we have 4 equations. Entonces, how many variables we have in that problem? How many variables? How many variables? How many? Guy, you pay attention.
3.
3 variables. The number of variables is 3. How many equations we have?
4.
4 equations. Now, when you subtract against -1, -1 have no sense. This is completely stupid conclusion. I suppose in the middle of the process, I discovered that one equation is linear dependent. I don't know. Don't try to see because maybe 2 and 3, maybe, right? Yes or no? Yes or no? 2 and 3 are linear dependent, right? Because you multiply by -1, for example, the equation 2, you get the equation 3. Yes or no? But
Yes,
in this
yes.
case, easy to see. I did intentionally. It's easy to see, but no always is possible. And when you have 40 equations, nobody can see this. Okay, no. Okay, entonces, pero bueno, okay. I want que elimination process, Ghost Jordan algorithm discover this idea. Okay, entonces let's move on to the matrix associated with that. The matrix is 2, 3, -1, 3. Remember, this is the column of the x, this is the column of the y, this is the column of the z, and the right hand side. So you don't need to write that, it's okay. I understand. 1, -1, -1, 0. And -1, 1, 1, 0. And 1, 3, and 5. This is a matrix, by the way, is a square matrix, is 4 by 4, right? So when there are coincidence in the number of row and number of column, this is called square matrix. Uh-huh. 1, 2, 3, 4, 1, 2, 3, 4. Okay, now apply reduce the row echelon 4, and we have surprise. Surprise. Let's see what happened. Let's move on to Geogebra. Okay. Okay. I typing. Do you see Geogebra or no?
Yes.
Okay. 2. Tap. 3. Tap. -1. Tap. 3. Enter. To change the line. 1. Tap. -1. Tap. -1 again. Tap. And 0. -1. +1. +1 again. And 0. Oh, I press tab, no enter. Don't change the map. The last is 1, 1, 3. I finish. This is important, guys. Checking see the sign or the number is okay. What do you think? I did okay or no? Because I make a mistake every day. Okay. The beauty of this is okay, you can type in this in Excel if you want. In Excel is more clear to edit and you copy and paste here. Suppose you have 20 equations, crazy. Then your Excel is bigger, the spreadsheet. You select, Control C or copy, and go to Geogebra and paste in the specific spreadsheet cell. Now you select, create matrix. Immediately you see the new matrix in algebra view. And now again, repetition, reduce the rows again. Reduce the row. Doesn't matter que capital letter or lowercase, they understand que redo set of the matrix F4. Center, boom. Wow, look at that, look at that. Elimination process discovered this idea. Let me show you. One more time you see the identity matrix 1, 1, 1, but you see the last row, que es 0, 0, 0, 0. That means que Gauss-Jordan algorithm discovered one dependent equation, and you can delete that part. Let me show you in the whiteboard. Actually, the thing we found was, okay, switching to that. Okay, I have 1, 1, and 1. 0, 0, 0, 0, 0, and 0. This is the famous identity matrix. However, remember we have 4 equations. So the 0, 0, 0, and 0. And the number is 13 over 9, 7 over 18, and 19 over 18. So the interpretation is elimination process, Gauss-Jordan algorithm discovered que this equation is dependent, and I delete that. Fuck that. So in conclusion, of the 4 equations that we have at the beginning, 1 is irrelevant to find the solution. And it's obvious that x is equal 13 over 9, y is equal 7 over 18, and z is equal 19 over 18. End the story. I finish. Not necessarily always happen, because maybe another example, we have not 1 dependent equation, but maybe you have 2 dependent equations. Entonces now it's more complicated. In this case, unique solution again. Unique solution. Get this, triple order, and 3D space. Okay, everyone follow me? Today,
Yes.
yeah. Today I'm planning, let me see, 6 examples, maybe. Okay, I have a lot, huh? Depending. Okay, I want to illustrate any possibility. It's very, very complicated to illustrate any possibility in 6 examples, so maybe I have more. This is example 5 now. Example 5 is, so I want to skip the part, well, no, skip nothing, okay. It's negative 4x plus y equal 5. No, I make a mistake. Is negative 4. Yeah, right. Yeah, negative 4. Negative 4x plus y equal 5. This is my first equation. My second equation is 2x minus y plus c minus w equal 5. Again 5. Equation 2. So don't expect in the real life the equation is expressed in standard. Standard is when you have coefficient x plus coefficient y plus coefficient z plus another coefficient something, w, and in the right hand side. Maybe in the real life the equation is completely disorganized, And you, in order to put in a standard in matrix 4, you put in a standard first. Okay, but it is okay. So now the last equation is C plus W equal 4. Equation 3. Okay, this is my system. You need to investigate what's going on that system. How many variables we have in the problem? How many variables? 4. How many equations? How many equations? How many equations? 3, right? That's obvious, no? 1, 2, 3. So what we have 1 degree of freedom. So in this case, it's impossible to be 1 point solution, because 1 point solution is 0 degree of freedom, no dimension. So maybe 1 line, or maybe no, maybe a plane, depending the amount of free variable that we obtain after apply the algorithm. Okay, let's do it. Now you write matrix 4. You write matrix 4, and matrix 4 is -4, 1, 0, 0, and 5. Remember, this is X, this is Y, this is Z, this is W. Second equation is 2, -1, +1, -1, and 5 again. Oof, it's a coincidence. And the third equation is no X, no Y, 1Z, 1W equal 4. And this is my system. By the way, the dimension is 3 by 5. Because we have 3 rows, because we have 3 equations, and 5 column, 1, 2, 3, and 4, que corresponde with the 4 variable, plus extra, que corresponde with the right hand side number. Now you put in the Geogebra and you apply reduced row echelon. And let's see what happens. Let's see what happens. Sorry. You see Geogebra? Scroll down. And you type in the tedious. Well, in this case, no, not too big. But if you have 20 equations, 40 equations, this is too long process. But it's too long process typing. You're supposed too long solving is okay. It's -4. -4. 1, 0, and 5. Enter. Second equation is 2, -1, 1, and -1, and 5. And the last equation is no X, no Y, 1Z, 1W, and the right hand side 4. This is my equation, my system, sorry. You see, can I make a mistake typing something or no? No? I appreciate so much. Can you help me see I make a mistake, no? I select, I create a matrix, boom. And now, again, the same idea. Of the matrix 5, no? Matrix 5. Boom. Boom. I get the answer. I get the answer. The answer is 1, 4, -3, -7, and 4. Okay. I need to understand what means that. Okay, the answer is, I come back. to the whiteboard. Okay, the answer I get was 1, 1, and 1. It's the famous identity matrix. Okay, now this is X column, Y column, Z column, and W column. Oof, it's the extra. 1, 4, 1, and the bar que separate right hand side. Right hand side is 2, 2, 0. No, mistake. I see another page. And -3, -7, and 4. Entonces, immediately I see that format. This famous identity matrix here. We have 3 by 3. We have 9 entry, 9 element. This is the famous identity matrix 3 by 3. And we have extra column, capital F, que, by the way, is 3 by 1, no? It's a vector. It's a vector. Let me use another color for the vector. It's a vector. I know it's a vector because one dimension is 1. No? And this is the right hand side. Okay, no problem. Now, we translate to the equation. The first equation is X plus W equal -3. Therefore, X is equal -3 minus W. So you somehow isolate the this is a non-free variable. Because it's obvious that the only free variable is W, no? And the non-free variable somehow is connecting by W. The first connection is this X equal -3 minus W. The second is Y plus 4W equal -7. Therefore, the Y alone is -7 minus 4W. And the third one is Z plus W equal 4. Therefore, C alone is 4 minus W. Okay, now this is a crucial moment to write solution set, solution object. Is this object living in 4-dimensional space? Because it's X, Y, Z, W. Impossible to see graphically. And you copy this expression 1 by 1, -3 minus W, -7 minus 4W, and 4 minus W, and W is free. Remember, free means all real number, right? By the way, the dimension for this object is 4 dimension, impossible to see graphically. However, the solution object is 1 dimension because contain only 1 free variable. Okay, it's a line in 4-dimensional space. That's the interpretation there. Okay, let's do it in the last problem, and that's it for today. Any question, guy? Do you follow me? It's confusing that you never see before in your life this? Oh yes, you see before.
This is new to me.
Is it new for you?
Mm-hmm.
And this is interesting, right?
Yeah, kind of.
kind of. Okay. Okay, let's move on to the next example. I want to erase that. Okay. Example 6 is the last one. Okay, we're doing today. Example 6 is 2x minus 2y minus 2z equal to. This is my first equation. My second equation is 2x plus 3y plus c equal to, and my third equation is 3x plus 2y equals 0. Equation 3. How many equations? How many variables? 3 variables, right? 3 equations. 0 degree of freedom. Degree of freedom equals 0. This is determinant. Maybe. See, some weird happen. We have one solution point living in 3-dimensional space. But the surprise is that maybe in the process we discovered that we have 2 equations that are dependent. And when entonces it's the same equation, entonces no, actually it's not 3 equations, it's 2 equations. I don't know. Okay, entonces now let me try in matrix language. You write 2, -2, -2 again, 2, 2, 3, 1, 2, 3, 2, 0, 0. The dimension is 3 by 4. And now you apply reduce row echelon form. And let's see what happens and what is the interpretation done. Okay. Okay. Let's move on to switching to Geogebra. Boom. Do you see that? Do you see or no?
Yeah, we see it.
It's 2, -2, 2, -2 again. 2, 3, 1, and 2, 3, 0, and 0. Enter. This is my system. Select the matrices or the array of number, and you convert to matrix. Wow, MP6 because that's the example 6. Now you copy now reduce row echelon, reduce row echelon of the matrix 6. Matrix 6. Bam, I get the answer. Interpretation distance. Let me copy this answer and the whiteboard. Okay. Here, over there. Do you see whiteboard? The answer is 1, 0, -2/5, 0, 1, 3/5. We have 0 here, we have 0 here again, and 0, 0, 0, and 1. Wow, interpretation of this answer. Pay attention because this is completely new for you. You never see this answer. You see that the last equation is, remember when you have 0, 0, 0, and 0, we delete this equation because it's completely dependent. But in this case, no. In this case, we have, remember, this is the x column, y column, z column, right hand side. And the last row, because the last equation is 0x plus 0y plus 0c is equal to 1. And 0x, 0y, and 0c is 0 equal 1. And this is completely false. So what is the interpretation there? What do you think is the interpretation? When you try to do something in mathematics and you get contradiction, what means that?
You get no solution.
Exactly. No solution. Okay? Entonces, this is the moment to summarize the information that we saw today. We have, for example, three possibilities. One possibility is one of the most common possibility. Is that we have the identity matrix. Nice, I like that. Maybe 3 by 3 or 4 by 4, the identity matrix. And we have the right-hand side number. Bam, bam, bam. 3, no? Because it's 3. Because you have unique solution. And remember, the identity matrix 1, 1, 1, and the rest is 0. 0, 0, 0, 0, 0. We have another possibility is that we have identity matrix. I don't know, suppose que es 3 by 3 also, yeah, bueno. Pero you have extra, capital F, 3 by 1. And this is the right-hand side. Entonces you have infinity many solutions. And the dimension for the solution is 1 because we have one column. But not all will happen. You see, next time I bring another more example to clarify that. In which you have, for example, identity matrix 3 by 3 or 4 by 4. And we have 2 extra columns. Oh no, or the see, 2 extra, 2 extra. 2 extra, this is 3 by 1, and this is another 3 by 1, okay, by the way, this and this together is 3 by 2, no? And right-hand side. In this case, you have 2 free variables. This is free variable, and this is also free variable. And the non-free variable is the variable that is contained in this part. So we have infinity many solutions, but the difference between this and this is that the dimension of the solution is 1 line, and here the dimension of the solution is 2 as a plane. And so, and the last scenario is that you, when you are doing reduced row echelon, okay, you have something, I don't know, but the last equation is 0, 0, 0, 0, and one number here, 20. And the rest I don't care. 1, maybe it's nice. 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, or another number, no important. It's not important. On the right hand side we have number. It's obvious that no solution because this equation is a contradiction. No solution. This is the way to interpretation this. So I recommend next time, we finish now. Next time, everyone in your laptop prepare 1 page of the Geogebra to solving some problem I bring extra, no? And we are doing together, right? So it's important that you learn very well the process, no? You create the view in Geogebra, edit the matrix, transfer to the algebra, apply and cast reduce row echelon, and finally write in the piece of paper an interpretation answer. Correct? Okay, guys. Now, one more thing. I appreciate so much. Can you checking in the blackboard your grade? Okay, any discrepancy, let me know. Because some students ask me, Professor, could you extend a little bit the test number 2 online? Yeah, I extended to yesterday. So there maybe I grade. Remember the reaching out due date was March 1st. Now the extension was March 7th. Now the student can improve. Let me know. Yeah, I fixed that. Okay. Super. Okay, guys. See, everything is clear.
Professor, I have a question.
Yes, sir.
Go ahead.
When's the next test due? Because I'm getting confused by a syllabus and Alex.
Well, I don't memorize this, but on the syllabus you can find. Okay,
I'm just
email.
asking because it's like 2 different dates.
Because no, you take the greater date always. No, I do everything in favor of my student. No, my student have more opportunity. No, but just in case you want to clarify, I don't have information now. Well, I have, but I need to open the syllabus. See, you email me, I reply with the correct information. Okay.
Okay, thank you.
Good. Bye, guys.
Have a good day, Professor.
Bye.